Hello everyone. Today we will discuss some very important topic, which is conservation of angular momentum. I have discussed many previous topics on rotation motion, which were ladder problems as well as bending of cyclists. So today we are discussing one of the important topic, conservation of angular momentum, basically. So basic definition deals with I omega is equals to constant. So as you know here, omega is the angular velocity. Omega here is the angular velocity, and I here is moment of inertia. Moment of inertia is moment of inertia. So in as in linear momentum, the formula was mv, where mass of a system is equals to velocity. That was the formula here. Mass is replaced by moment of inertia, and angular velocity replaced the linear velocity. So that's why it is angular momentum. This is angular momentum, and when it is a constant, what is meant by a constant means as if tau net is 0. When tau net is 0, as you know the relation that tau is equals to dl by dt, where dl is the angular momentum, tau is equals to dl by dt, and if t, that is net tau, is 0, then I am writing it here, 0 is equals to dl by dt, dl by dt. So dl will be a constant here, like this. Like this, it is all related with conservation of angular momentum. When the net torque acting on the body is 0, we can conclude that the system is in angular momentum. That is conservation of angular momentum. I will demonstrate this by an example. What is the example here? So you have seen when the uh, if you are NCRT gives an best example that if you and your friends can demonstrate this, there is a chair, a computer or a PC chair, which has wheels down. So make your friend sit on that kind of chair and give a full that is angular velocity, which is omega, and if he spreads his hand, if he spreads his hand out, then you will observe that the angular velocity is decreasing, the speed is decreasing. What is the reason for that? What is the reason for that? So when hands are out, that is when your friend is in this position, I'm drawing it, that is his hands are out. So here I will increase, that is moment of inertia will increase, and that's why the omega will decrease, so that the sum becomes a constant, so that the multiplication becomes a constant. So what is the different case in this? If your friend places his hand close to his chest, then you will observe that the speed is increasing. What is the reason for that? The second case, I am drawing it here. Places his hand towards the chest, then you will see that I omega I will decrease and omega will increase. That is, angular velocity is going to increase, and that's why to compensate it is a constant. Means here your friend is using conservation of angular momentum, and a question comes that belly dancer belly dancer how she is changing or altering the speed. So she's altering the speed by the use of conservation of angular momentum. So this, with the help of the example, I will recall it again that when you give a angular velocity to the chair and your friend is spreading the hands like that, like this, he's spreading the hands, the I, that is moment of inertia, mass concentration बेटा तेरा increase होगा, इसलिए moment of inertia increase होने वाला है. Moment of inertia, if it is increasing, the omega should decrease ना. The omega should decrease. Therefore, you can see that the speed of your friend is decreasing. But in the second case, if you are again giving an angular velocity to the chair and now he places his hands here, then simply you can say that moment of inertia is decreasing, and that's why the angular velocity is increasing, and you can observe that. Means the changes in velocity could be done using the concept of angular conservation of angular momentum. So this is all about angular momentum and how it applies to real life examples. Like in case of a belly dancer, she uses conservation of angular momentum to change her speed. So this was all about today's video. If you loved this video, just give a thumbs up and comment me which are difficult topics, and I will provide the link in the description for the topics ladder problems and pending of cyclists. Thank you for watching.